space, let f bar be a vector point function defined on the curve C. Divide C into n segments by the points P0, P1, P2, so on Pn. Let the position vectors of these points be R0 bar, R1 bar, R2 bar, so on Rn bar. Let delta Ri bar is equal to Ri bar minus Ri minus 1 bar. Let Yi bar be the position vector of any point in the part of the curve Pi minus 1 to Pi. Consider the sum of the product sigma I is equal to 1 to n f bar into yi bar into delta Ri bar. As n tends to infinity, that is delta Ri tends to 0, the limit of the sum sigma I is equal to 1 to n f of yi bar into delta Ri bar is known as the line integral of f bar along the curve C. It is denoted by integral over the curve C f bar dot dr bar. Thus, integral over the curve C f bar dot dr bar is equal to limit n tends to infinity or delta Ri tends to 0, sigma I is equal to 1 to n f bar of yi bar into delta Ri bar. Note 1. By considering the cross product instead of the product of the line integral can also be defined as integral over the curve C f bar cross dr bar is equal to limit n tends to infinity or delta Ri tends to 0 summation I is equal to 1 to n f of yi bar into delta Ri bar. Note 2. If the curve C is the closed, then the line integral of f bar along the C is denoted by line integral over the C f bar dot dr bar. Suppose f bar is equal to f1 I bar plus f2 j bar plus f3 k bar and C is any smooth car, then integral over the curve C f bar dot dr bar is equal to integral over the C f1 I bar plus f2 j bar plus f3 k bar into dx I bar plus dy j bar plus dz k bar. By doing the dot product on these two, we will get the integral over the C f1 dx plus f2 dy plus f3 dz. The integrand f1 dx plus f2 dy plus f3 dz is to be reduced to a function of a single variable using the representing the equation of the curve C. Case 1. If C is represented as y is equal to p of x, z is equal to q of x, a less than or equal to x less than or equal to b, then integral over the curve C f1 dx plus f2 dy plus f3 dz is equal to integral a to b f1 of x comma p of x comma q of x plus f2 of x comma p of x comma q of x into p dash of x plus f3 of x comma p of x comma q of x into q dash of x whole dx. Case 2. If C is represented in parametric form x is equal to p of t, y is equal to q of t, z is equal to r of t, and a less than t less than b, then integral f1 dx plus f2 dy plus f3 dz is equal to integral a to b f1 of p of t comma q of t comma r of t into p dash of t plus f2 of p of t comma q of t comma r of t into q dash of t plus f3 of p of t comma q of t comma r of t comma r dash of t whole dt. Geometrical interpretation of line integral. Work done by force. If f bar is a force acting on a particle moving along an arc AB, then the work done during a small displacement dr bar is f bar dot dr bar. The total work done by the force F during the displacement from A to B is given by the line integral C f bar dot dr bar. As shown in the figure, dr is the small displacement caused by the force F. Circulation. If V bar represents the velocity of a fluid particle and C is a closed, then the integral V bar dot dr bar is known as circulation of V bar around the curve C. If integral V bar dot dr bar is equal to 0, then the field V bar is called conservative. That is, no work is done and the energy is conserved. If the circulation of V bar around the every closed curve in a region R vanishes, then V bar is said to be irrotational in R. Let us observe some solved examples on line integral.